morning, students. I welcome you all to Burhan Mumbai Municipal Corporation Education Department, online education for English medium. We are conducting this online session for class 10th, subject science, and the topic which I am going to teach you today is refraction of light. And in this, the subtopic which we are going to learn is what is refraction and what are the laws of refraction. This is my first session, students. My name is Mrs. Bushra Ahmed, and our General Nodal Officer name is Mrs. Roshali Kalavli. Students, I am from Kajupara MPS Secondary School, Kulla. So students, today we are going to discuss chapter number 6, that is refraction of light. Okay. Now, by reading the topic only, refraction of light, what comes in your mind that what we are going to learn in this chapter? Yeah, might be we are going to learn about light, right? What are the properties, some concept related to light. Students, in last standard, that is in standard 9, you have learned one chapter that is refraction of light, right? In that, what you have learned? You have learned what is light, what are the properties of light. Then you have also learned reflection of light, laws of reflection. So many things you have learned, right? So students, today, before going to a main concept, refraction of light, we are going to just revise some topic which we have learned in class 9. So that when we are going to learn this, our basic knowledge will be fulfilled and we can easily understand the further concepts. Okay. Now in this chapter, what we are going to learn, students, what are our learning objectives? Our learning objectives is we'll discuss about the laws of refraction and rules of refraction. Okay. Then second, what we are going to learn, we are going to understand the concept of effect of atmospheric refraction. In atmosphere, students, how the concept of refraction is take place, what are the effects of this atmospheric refraction, we are going to understand that. Again, we are going to understand the concept of total internal reflection and rainbow formation. In this chapter, students, we are also going to learn how this rainbow in rainy season, see, sometimes we see rainbow. So how this rainbow formation take place, this all things we are going to learn in this chapter. And in this chapter, this all things I'll make you discuss in 4 sessions. Today is my first session. Okay, students. So let's proceed towards our topic now. Now see, students, first we'll see refraction of light. What do you mean by reflection of light? See, reflection is when light bounces off an object. Light reflects from a smooth surface at the same angle as it hits the surface. Now you will see, students, can you see a picture below? See this figure, can you see a plane mirror here, right? This plane mirror is having he's having a smooth surface, right? Plane surface. So students, when light incident on such a smooth surface, it bounces off. It bounces off. And this property of light is known as reflection of light. This is only this definition want to tell us. Now see, the first line, that is refraction. See, reflection is when light bounces off an object. What is, students, reflection is? Reflection is when light it bounces off an object. Which object, student? Light reflects from smooth surface. From which surface? Smooth surface. If the surface is smooth, then only it will reflect. And if it is smooth, if the surface is smooth, it will reflect at the same angle as it hit the surface. And if the surface is smooth, so the angle which it hits, it bounces back with the same angle. Now see, the ray which is inciding on this plane surface, student, it is known as incident ray. And the ray which is bounces back from this smooth surface, that is known as, students, reflected ray. Okay, and can you see a straight line here? This is nothing but a normal. So the angle which is from normal to the incident ray, that is known as incident angle, and angle from normal to the reflected ray, that is R, that is nothing but a reflected angle. Okay, now see, students, in this reflection of light, angle of incidence, that is I, is equals to angle of reflection, that is small r. And this is also known as, students, laws of reflection. Laws of reflection is nothing but angle of incidence is equals to angle of reflection. Okay, so I hope you have understood this. This is only for your revision purpose, students, so that you can rewind the topic which you have learned before. Now, students, we are going to learn some interesting properties of light. Okay, you're going to enjoy it. Now see, what are the properties of light? Now see, the first property of light is light travels in a straight line. Everyone used to tell you that light travels in a straight line, but how can you justify your answer that light travels in a straight line? Can you see this photograph here, students? This figure here? See, one candle is lightened up and one person is seeing that light with the help of this straight pipe. When he is seeing the lamp with the help of this straight pipe, what, students, he can easily able to see, this person is easily able to see the light of the candle. Means light is reaching to its eyes. But students, when he bent this pipe from between like this, so what happened? Light gets blocked here because light is traveling in a straight line. So this person will not able to see the light of the candle. So this activity, what this activity is going to explain us, this activity is going to tell us that light travels in a straight line. Hence, when this pipe is bent, the person is not able to see the light of a candle. If light doesn't travel in a straight line, so in this condition also he can see the light, but he's not seeing it. So it means that it is proof that light always travel in a straight line. Okay, students, the first line, I hope my students have understood this. Okay, now students, I'm going to explain you the second properties of light. What is the second property of light, students? Because of this means light is traveling in a straight line. Because of this, if an object lies in its path, a shadow of the object is formed. Now see, as light travel in a straight line, and if some object lies in between that, so students, what happens? What happens, students? If an opaque object, means if some object is placed in between of that light, so what is formed? Shadow is formed. See, whenever you are walking in a light, see, in a noon time, in an afternoon time, or in an evening time, when you're walking on a road, you can see the shadow of yours. Again, Can you see a photograph below, students? Can you see a tree here? See, can you see the shadow of that tree? Right? Why the shadow is formed? Because this object lies in a path of the light, and it blocks the path of the light, and then only the shadow is formed. So due to light, what is formed, student? Shadow is formed. This is the second property of light. Now see, this shadow changes. Third point we are going to discuss. These shadows change due to change in relative position of the source of light and the object. Now, what does this third point means? Now, see, students, in the morning when sun rises, in the noon time, in the afternoon time, and when the sun sets, every time the position of the sun is changing. So can we see the same shadow every time? No, right? We see there is a change in the shape, in the position of the shadow, right? Because why? Because there is a relative motion of the source of light. Source of light is what? Here I'm considering sun. Sun is a source of light. So when sun is changing its position, what we are seeing? We are seeing that there is a change in its shadow also. Okay. So same, see, students, you can do one activity at your home also. Everyone is having study lamp, yeah, at your home. So what you do, you put any object in front of that light. Okay, your compass box, your tiffin box, anything, and you see the shadow of that object. And what you will do, slowly you change the position of your study lamp. Okay, so what you will see that there is a change in the shadow also, right? So due to change in the position of the source of light, there is a change in shadow also. Okay, so I hope you have understood this third point very nicely. Now see, student, fourth point. But light can bend under some special circumstances. Now what this is telling us, that light can bend under some special circumstances. Now what are that special circumstances, students, that we are going to learn in this chapter? Now I hope this all introductory part you have understood. The basic knowledge of light is now you know, everyone. So now I am going to start our topic, that is refraction of light. Okay. Now see, students, before going to learn what is exactly the refraction of light, we will perform some activity. Now see, to perform this activity, there are some materials which is easily available at your homes. You have glass, glass in which we drink water. Can you see a picture of a glass here, right? You'll need a 5 rupees coin or any coin, okay? Then you'll need a pencil, a metallic vessel. This much things you'll need for this activity. Now students, if you can perform this activity simultaneously with me, so you can easily understand what I'm going to explain you. If you have a transparent glass with you right now, so can you fill that glass half with the water, everyone? So take a transparent, what we are going to learn here in this activity first. You have to take a transparent glass and you have to fill it with water. Everyone, students, take a glass of water. If you're having a glass that is transparent glass with you, just bring that transparent glass and just fill it with water, everyone. Okay. Now what you have to do, students, you have to dip some portion of the pencil vertically. Vertically means seedha. Okay. First, what you will do, you have to dip, not as it is showing in the figure. First, you have to dip some portion of the pencil vertically in the water. And what you will do, you have to observe the thickness of the portion of the pencil which is in water. Do that, students. Dip some portion of the pencil vertically in the water and observe the thickness of the portion of the pencil. What you will see, students? You will see that the portion of the pencil which is underwater, it is thickened up, right? It is thicker than the upper part, right? See, now what you will do, students, second, now keep the pencil inclined to water surface and observe its thickness. Now see, as I have inclined now, first what I have told you, make it, dip the pencil vertically, okay? Now what you will do, you will just incline the pencil, just incline it in the water. What you will see, students, again, you will observe that in both the cases, the portion of the pencil which is inside water appears to be thicker than the portion above the water, right? Can you see that, students? See in the photograph, you see now the portion which is inside the water, it is thicker than the portion of the pencil which is above, right? Now, in second, when we have dipped the pencil in an inclined position, students, in that second case, what we will see, the pencil appears to be broken near the surface of the water. What you see here, see, can you see the pencil to be broken up near the surface of the water? It seems like this pencil is broken up, right? It is seeing now. Now, why does this happen, right? A big question comes in my mind that when I am dipping this pencil in a water, it seems that the portion is thickened up. And when I'm inclined, when I'm dipping the pencil in an inclined position, again, that the portion which is inside, it is thickened up and it seems to be broken near the surface of the water. What might be the reason behind it? See, students, you have to ask the question to yourself. When you will start asking question to yourself, you will be able to answer the queries. You will be able to understand what is the science behind everything which is around you. Okay, so this answer, we will see what will be the answer. But before going to answer, again, one very nice activity we are going to see related to the same question. Now, say student, for this, what you have to do for the second activity, you have to take one metallic vessel and you have to take one 5 rupees coin. Now, see step by step what you have to do. Just see. Number first, keep a 5 rupees coin in a metallic vessel. What you have to do, students? You have to keep a 5 rupees coin in a metallic vessel. Can you see a vessel here? So you have to keep it at the bottom. Now, slowly go away from the vessel. What you will do, students? You will slowly go away from the vessel. Stop at the place when the coin disappears. What you have to do, student? You have to see that 5 rupees coin and you have to slowly go away from the vessel and you have to stop at a position where you cannot able to see that coin. When the coin disappears from your eyes, at that point you have to stop. Then what you have to do? Keep looking in the direction of the coin. You have to continuously look in that direction only, okay? Direction of a coin. Now you have to take the help of your brother, sister, or your friend which are with you right now. And what you will tell them, ask your friend to slowly fill water in the vessel. What you will do, what you will request your friend student to slowly fill the water in that vessel. Now what magics come? See, when your friend fill water in the vessel, what you will see, students? You will be able to see the coin once the level of the water reaches a certain height. When a water reaches to a certain height, you will again able to see that coin once again. And where you will see in the see in this figure, students, the coin is originally it is kept in the bottom, but now as you fill water, what you will see, there will be a change. It will, you see that the coin appears above. There will be, you will see that there is a change in the position, but originally the coin is kept at the bottom. So how these changes take place, students? How you can, when there was no water, you were not able to see that coin, but now as your friend has filled water and the water has reached some height, again you are able to see that coins on some other position, right? So again, same question comes in my mind, that why does it is happening? What is the science behind that? What is the reason behind that? So students, the reason behind that is the property of a light, that is nothing but refraction of light. What, students? Refraction of light. Now we are going to learn what is refraction of light. I hope this, both the two activities you have understood very well. Okay. Now students, see, in both the above activities, the observed effects are created due to the change in the direction of light while coming out of water. Now see, in both these activities, students, what? In both the activities, the effects which we are created, that are due to what? Due to change in the direction of light. When the change, when there is a change in the direction of light which is coming out of the water, this is due to that. Now what was that? Now see, can you see the definition which I have typed in a bold letters? What is that? Now we are going to learn that. Okay. Light changes its direction when going from one transparent medium to another transparent medium. This is called the refraction of light. Now see, students, air, it is a transparent medium. You can see things, right, in an air medium. Then water. Water is also a transparent medium. You can see things in waters also, right? So students, when light travels from one transparent medium to another transparent medium, what happens, students, at that time? Light changes its direction. At that time, what happens? There is a change in its direction, and due to this effect only, students, we can see the effect why the pencil was looking thicker in a water. Why? When we incline the pencil, it seems broken at the surface of the water. Why initially the coin was not seen, and as the water reaches to some height, we can able to see the coin, but at the different position. This all is due to, students, this refraction of light, because light changes its direction when it is going from one transparent medium to another transparent medium. In both the cases, light is traveling from two medium, that is air medium and water medium. Both are transparent medium. Hence, students, there is a refraction of light. There is a change in its direction. And we can see all that effects which we have seen in activity number 1 and in activity number 2. Now, I hope my students has enjoyed these 2 activities very well. Okay. Now, students, we are going to learn this refraction of light again with the help of activity number 3. Now, see, this activity you can do at your school when your school is going to open. Okay. Now, what you have to do, students, in this activity, you have to take one blank white paper. Okay. Take a blank white paper and you have to keep a glass slab. Now, you will tell me, ma'am, what is glass slab? Glass slab is, students, it is a thick glass material. It is a thick glass which is in a rectangular shape. See, like this. In a rectangular shape it is, and that is very thick. Okay. So that we called as glass slab. Now, see, you have to take a blank paper, white paper, as it is shown in the figure, and you have to put that glass slab on that paper. Now, what you have to do, step by step, okay? Don't read next point. When I'm explaining you one point, just concentrate on that point only. Then only you can understand each and every point, which I'm going to discuss with you. Now, see, number first, keep a glass slab on a blank paper and draw its outline PQRS as shown in the figure. Now, see, they put this glass slab on this white paper and draw this outline PQRS. Can you see here, students? Right? Okay. Now, what you will do second? Draw an inclined straight line on the side of PQ so that it intersects PQ at N. Now, what you will do? You have to draw one inclined straight line at the side of PQ. Can you see PQ here? At that time, draw one N normal to it and draw one inclined straight line. Okay. Now, what you will do? Pierce 2 pins vertically at 2 points A and B along the line. What you have to do? You have to place 2 pins. Straight pins, you know, paper pins, students. That pins you have to pierce at position A and position B. This much everyone understood? Still here what we have done? Right? Now, what you have to do, students, you don't have to remove the glass slab, okay? You have to keep that glass slab as it is. Now, what you will do? Look at the pins A and B from the opposite side of the slab and pierce pin C and D vertically so that the image of A and B are in line with C and D. Now you start telling, ma'am, we've not understood this third point. I'll make you wait. Now see, students, what we have done first, we have put 2 pins at the position A and B. Now, what is the opposite side, students? SR. Now the glass slab is placed as it is. Now what I am doing, students, from this side SR, I am watching out these pins A and B. And what I am doing, I am putting out 2 pins at the position C and D. How? So that when I'm looking from the glass slab, it seems that it is in a straight, in the line of the pins A and B. Okay. And now I have, by looking the pins A and B from the glass slab, I have put pin C and D in a same line as that of A and B. Now what I am doing, students, what see? Now remove the clip and pins and draw a straight line going through points C and D so that it intersects SR at M. Now what? Just remove these 2 pins C and D and draw a straight line where it is intersecting at normal M, at which side, students? SR. Now what we see that? See. Now join points MN, observe the incident ray AN and emergent ray MD. Now see what we have to do. Now remove this glass lamp. Now you have to remove this glass lamp. And what you have to join, students? Can you see a point N and M here? You have to join this line. What you will see, students? We will see that there is a change in the direction of light. See, incident light and emergent light. Incident light is what? AN. Can you see AN here? And emergent is MD here. Yeah. Incident light is what? The light which is getting incident. And emergent light, what we say? Which is coming out. That is known as emergent ray. Okay. So students, when we remove these clips and pins and we just join all this line, what we see, students, that there is a change in the direction of light. Now see fourth point. Now remove the clips and pins and draw a straight line going through point CD. And so it intersects, this we have seen. Now see, students, this we have seen, okay? Now, what are the conclusion which comes after this? The first refraction. The first refraction occurs when light ray enters the glass from air at N on the side PQ. Now see here, student, 2-time refraction is occurring. See, number first is when the light ray is entering from air medium to the glass medium, right? From air medium to glass medium. So there is a change in the direction of light. The second refraction occurs when light enters air medium through glass medium at point M on the side SR. Now see on the side SR, this is the time when second time refraction is taking place. How second time refraction is taking place? Here, students, the light ray which is coming from the glass, it is coming out in the air medium. From glass medium, it is coming out in the air medium. So this is what, students, second time the refraction is taking place. Okay, this my students has understood nicely. I hope you have understood how 2 times refraction is taking place here. Okay, now third time. Now see, for the first refraction, the angle of incidence is I, while for the second it is I1. Now see in the figure, we have seen angle of incidence for first refraction is I, and for the second refraction we have taken is as I1. Okay. The angle of reflection at N, capital N, is R. Note that I1 is equal to R. Now see, angle of reflection at capital N, when light is refracted from air medium to glass medium, so angle of refraction is R. And what, students? This angle of refraction of first refraction is equal to the angle of incident of the second refraction, that is I1. Means I1 is equals to R. Can you see this? Right? So what you can see, students, if I1 is equals to R, so can you tell that the I which is incident angle of the first refraction can be equal to emergent angle, that is E, right? I will always should be equal to E then. In the second refraction, the angle of refraction is E, which is equal to I, right? On both parallel side, PQ and RS of the glass slab, the change in the direction of light ray is equal but in opposite direction, right? In both the cases, from PQ and SR, in both the side, the change in the direction of the light are equal but in opposite direction. We can justify that, right? Hence, R is equals to I1 and I is equals to E, right, students? Thus, the light ray MD emerges from the glass slab is parallel to the incident ray AN on the side PQ of the slab. Hence, students, it is equal and opposite. Hence, the incident ray and emergent ray, they both are parallel to each other. If these changes are not equal and opposite, then incident ray and emergent ray, no, they not be parallel to each other. They might be in some inclined and other position, right? But the emergent ray is somewhat displaced with respect to the incident ray. Now, see, student, this whole activity, what this activity want to tell us, students, want to explain us? This whole activity number 3, we want to explain us refraction of light, that how when light enters from air medium to the glass medium, and second time from glass medium to the air medium, how there is a change in the direction of the light. And when there is a change in the direction of the light, in both the situation, the changes are equal and opposite. As it is equal and opposite, then only I1 is equals to R and I is equals to E. And then only incident ray is parallel to emergent ray. This is what this activity wants to explain us. I hope I have cleared each and every point to my students. My student has nicely understood this activity, and you can easily tell what is reflection of light now, right? Okay, students. Now we are going to see some concepts. You have to use your brain power here, okay? Now, see, students, we have seen refraction of light. So some questions comes in my mind, so that I have to discuss with you. Is that the same question comes in your mind also, students? Now see number first. Will light travel through a glass slab with the same velocity as it travels in the air? Tell me, students. Will the light travels with the same as the glass slab with the same velocity as it is traveling in the air? No, right? If it will travel in the same velocity, then there will be no change in the light direction. But we are seeing that there is a change in the light in the direction, right? Light's direction. So students know light will not travel through a glass slab with the same velocity as it travels in air, because the glass slab blocks the path of the light, right? Light will not travel with the same velocity as it is traveling in the air, okay? When it is traveling in a glass slab. Now, students, second question which is coming in my mind is that, will the velocity of light be same in all media? Will it be same, students? Will the velocity of light be same in all media? No. The velocity of light will not be same in all media. The denser the medium, the slower the light will travel. And it travels the maximum velocity in air or vacuum. Now see, students, this is very nice answer. Now see, in different medium, students, light is having different velocity. It does not have same velocity in every medium. Now see, as the medium become denser and rarer, if I'm taking two mediums, that is air medium and a glass medium. So what will be the rarer medium here, students? Air will be the rarer medium and glass will be the denser medium. If I'll take two mediums as an example, such as air medium and water medium. So what will be the denser medium here, students? Denser medium will be the water. and rarer medium will be the air. So student, when light travels in the denser medium, so there is a the light travels slower. Its velocity get decreased, its speed get decreases. And light travels with maximum velocity in air or in a vacuum. In this two medium, air or in a vacuum, the speed of the speed of the velocity, the velocity of the light is maximum in air and vacuum. So I hope you have understood these two questions very well now. Now students, we are going to see laws of refraction. What do you mean by laws of refraction? This much you have understood, refraction of light, then some concept which is related to refraction of light, activities which we have discussed, right? Now we are going to learn, students, laws of refraction. Now can you see here light ray entering a glass slab from air? Now see here students, there are two medium, air medium and glass medium. Now you can easily tell me what is rarer medium here? Air is the rarer medium. What is the denser medium here? Glass is the denser medium, right? And when light will travel from rare medium to denser medium, there will be change in the direction of light. See, light ray entering a glass slab from air, it as shown in the figure. Now see, here AN is the incident ray and NB is the refracted ray. Now see students, here you have shown you the incident ray and the refracted ray. Now in both the scenes, students, see number first. Incident ray and refracted ray at the point of incident N are on the opposite side of the normal to the surface of the slab at that point, that is CD, and the three incident ray, refracted ray and the normal are in the same plane. See students, I'll make you understood. Now see, incident, step by step we'll see. Incident ray and refracted ray at the point of incident N are on the opposite side of the normal. Now see, this is incident ray, this is refracted ray, and this CD is the normal, student. So this incident ray is on the opposite side of this refracted ray with this normal. Okay, this first line want to explain us. Okay, now see the three. What are the three things? Incident ray, refracted ray and the normal, they all are in the same plane. Now see all this, the incident ray, the refracted ray and this plane, they all are in the same plane. This normal, this incident ray and this refracted ray, these all three things are in the same plane. This is only what the first law of refraction want to tell us. This is the first point what the law of refraction want to tell us, that all these three things are in a same plane. They all are in a same plane. This is the first point. Very simple. Okay. Second, for a given pair of media, what are the pair of media here? Glass media and air media, right? First media is air and second media is glass. The ratio of sin I to the sin R. Now I is the angle of incident here and R is the angle of refraction. So students, here the ratio of sin I to the sin R is always constant. Okay, this is the second law of reflection, very important, that ratio of sin I to the sin R is constant. In detail, this law of reflection I will make you understood in my second session. Okay, just reminded, the ratio of sin I to the sin R is always constant. This is the law of refraction. Here I is the angle of incident and R is the angle of refraction. So these are the two laws of reflection, that all these three things, and incident ray, refracted ray and normal, they all lies in the same plane. And for a given media, given pair of media, the ratio of its sine of incident angle to the sine of refracted angle is always constant. This is students' laws of reflection. I hope my students has enjoyed my session very well. You have understood each and every point. Now there are some assignment which I'm going to give you students. So just note down this question and you have to write it down in your notebook and make it check with your science teacher. Number first is explain properties of light. You have to explain properties of light. Second, you have to write an activity to explain refraction of light. Any activity which I have explained you have to write that activity and you have to explain how refraction of light takes place. And you have to write the laws of refraction. Okay, students, this is the assignment for you. Thank you for watching my session. I hope my students have enjoyed my session. Thank you so much. Thank you so much, ma'am.
Yeah, thank you, ma'am. It was very nice explanation, very effective. So that students must have really understood the topic which I've taught you today. It was really,
so much,
really, it was very nice. Students, I hope you have understood the topic which is taught by ma'am. Already you have studied that part of the topic in 9th standard, but even though last year was also our online session, today you must have got all the points, all the terms cleared, because ma'am has explained it with the help of diagrams very nicely. So thank you, ma'am. Still any doubts, students, you can raise your hands.
Yes, thank you. Yeah, students, any doubt?
I don't think so. They must be having any doubts. It was really very nice.
Thank you, ma'am. Thank you so much. So, ma'am.
Yeah, we'll stop here. Thank you.